In this lesson, you're going to learn how to graph a quadratic equation using a table of values. Let's take a look at the first example. If you look at this quadratic equation, y equals x squared plus 2x minus 3, in a previous lesson you learned how to find the vertex. You used the formula to find the x value of the vertex, which was x equals negative b over 2a. And this is shown just above here. And this helps you find just the x value of the vertex. Now when you're making a table of value, that will give you a more precise parabola. So the -1 we actually stick in the middle of the table because this represents the vertex and the vertex cuts your parabola in half. From there, we would plug the -1 into the equation wherever you see an x. So the x squared and then the 2x, we're going to replace those x's with -1. We'll go ahead and simplify the right side of the equal sign, and that will tell us our value of y for the vertex. So we would get 1 plus -2 minus 3, which gives us -1 minus 3, or -4. And if you look back up at the table, that's what we have in the table. The question is, where do we go from here? Once we know the vertex, we need some additional points. However, if you look down at the parabola, we need to make sure that we find points to the left of the vertex as well as to the right of the vertex, so that we have points representing each side of the parabola. So the way that we do this is we start with the x value of the vertex. We're going to choose two values, one or two values, it doesn't matter which, one or two values that are less than -1, and I chose -2 and -3, and then one or two values greater than -1. So the ones that are less than -3 and -2, those will represent the points on the left side of the parabola, and the two numbers that are greater than -1, the 0 and the 1, those represent the 2 points to the right of the parabola, or of the vertex. Okay, and then from there, just like you did with the vertex, you pick your x values, and then you just plug them into your equation for x one at a time. So you would start by plugging in where the x's are, the -3, and then you'll calculate that and you would get 0. And I'll show you an example of this in a moment. And then you'd plug in the -2 for both x's and calculate the quadratic, and you would get -3, etc. And once you have your 5 points, then you just plot them and then draw your parabola. Okay, so let's actually walk you through a problem from start to finish. So here we have y equals x squared minus 6x plus 2. So the first thing you want to find is the vertex. So we're going to use x equals -b over 2a, which is the formula for the x value of the vertex. So we need to identify a and b for this. So we know a is 1 and b is -6. So we're going to bring our negative over from our formula and replace the b with -6. In the denominator, we'll bring down our 1, so we have 2 times 1. If we simplify that, we'll have 6 over 2, which equals 3. And 3 is going to go in the middle of our table for the x value of our vertex. Now we're going to find the y value of the vertex. So we're going to plug in the 3 for the x's in our original equation. So it'll be 3 squared minus 6 times 3 plus 2. And when we simplify this, we're going to get 9 minus 18 plus 2, which equals -9 plus 2, or -7. So 3, -7 is going to be our vertex. Now, remember, we need to find at least one point to the left of the vertex and then at least one point to the right. So from the x value of the vertex, which is 3, we're going to pick one number less than it, so I'll pick 2, and one number greater, which is 4. And then just like we did up here, we're going to plug in the x value. So we'll start with the 2. We'll plug that into the equation and find y. So we'll have 2 squared minus 6 times 2 plus 2. And that would give us 4 minus 12 plus 2. And 4 minus 12 is negative 8. And negative 8 plus 2 is negative 6. So I'm going to put that up with the 2 in the table. So one other point we're going to graph is 2, negative 6. Then the last one is the 4. So I'm going to plug the 4 in now for x and solve for the last y value of our ordered pairs. So we'll have 4 squared minus 6 times 4 plus 2. So 4 squared is 16 minus 6 times 4, which is 24, plus 2. From here, 16 minus 24 is negative 8, and negative 8 plus 2 is negative 6. Now, I don't know if you can see this, but notice how the y values of the first and the last point are both the same. They're both negative 6. And that should be true each time, as long as the numbers you choose are the same distance from the x value of the vertex. So 2 is 1 less than 3, and 4 is 1 more than. So as long as you choose numbers that are equal distance from the x value of the vertex, your y value should come out the same because a parabola is symmetrical. So now we're going to graph these points. I'm going to start with the vertex. So 3, negative 7 is right here on your graph. Then you're going to graph 2, negative 6, which is right here, and then 4, negative 6. So notice it's symmetrical. So then from there, I could either find 2 more points, or I can at least graph this, which is a little more precise than what we've been doing prior to this. Okay, let's look at the next slide. Okay, in this next slide, we're going to also introduce the axis of symmetry. So if you look at the parabola to the left right here, you'll notice a red dotted line right down the middle of the parabola. This is called the axis of symmetry because it's the line that divides the parabola in half. And there's actually an equation attached to the axis of symmetry. Because if you just had that red line and I asked you for the equation, because it's cutting through the x-axis at 3 and it's a vertical line, the equation that represents that vertical line is x equals 3. Another way to think of it is this. You look at the vertex, and if you write the ordered pair of the vertex, it's going to be 3 for x and negative 4 for y. The axis of symmetry is always going to be x equals whatever the x value of the vertex is. Every time it's going to be the x value. So if you look at this graph below and to the right, if you were to draw a dotted line right down the middle through the vertex, again, if you were to write the ordered pair that represents the vertex, it would be negative 1, 5. The axis of symmetry would be x equals whatever number is the x value of the vertex, so it'd be negative 1. And notice if you actually look at the line, it's touching the x-axis at negative 1. So the axis of symmetry is an actual equation that represents the line that cuts the parabola in half. Okay, and we're going to be identifying this as well in just a moment. Okay, so if you look at these two equations, or these two parabolas, if we were to draw an axis of symmetry for this first parabola, you really just have to go to the x-axis and see where it's touching the x-axis, which is at 3. So it's just x equals 3. But again, the other way to do it is to identify the ordered pair of the vertex, which is 3, negative 4, and the number in your equation should match the x value of the vertex. On the parabola below that, if you draw your axis of symmetry, notice it's cutting through where x is negative 1. And if you were to write the vertex, it would be negative 1, 5, and these match. Okay, so let's go back to this. We're also going to talk about the domain and range. Okay, so let's kind of do this in full, and then we're going to identify the axis of symmetry, and I'm going to show you how to do the domain and range. Okay, so first we want to find the vertex, so we're going to start by using the vertex formula for the x value, which is negative b over 2a. So we know that a is 1 and b is 4. So we're going to replace the 1 or the b and the a in the formula with the 1 and the 4. So we have negative 4 over 2 times 1, which simplifies to negative 4 over 2 or negative 2. So this is going to be the x value of our vertex. From here, we're going to plug in the x value of the vertex, which is negative 2, into each x in our equation. So if our equation is x squared plus 4x plus 8, we're going to plug in the negative 2 in both of those spots. So that would give us negative 2 squared plus 4 times negative 2 plus 8. If we simplify that, we're going to get 4 minus 8 plus 8, which is going to give us 4 minus 8 is negative 4 plus 8, or 4. So our vertex is at negative 2, 4. Now remember, from here, you need 2 more x values. So you're going to pick one x value that's less than negative 2, so that'd be negative 3, and one that is greater than negative 2, which is negative 1. And those will now be the numbers that you plug in for x into the equation to allow you to find y. So now we're going to plug in negative 3. So we're going to have negative 3 squared plus 4 times negative 3 plus 8, which is 9 minus 12 plus 8. And then 9 minus 12 is negative 3, and negative 3 plus 8 is 5. So that would be the y value of our first point. Now remember, this 5 should end up being the same as the one below, but we're going to go ahead and figure it out to make sure in case we made a math error in the first point. So we'll have f of negative 1 that we're going to be plugging in. So we'll have negative 1 squared plus 4 times negative 1 plus 8. And this gives us 1 minus 4 plus 8. And then 1 minus 4 is negative 3, plus 8 is 5. And we wanted to get 5 again, just like we did in the problem before that. Okay, because we wanted our y values of our first and third point to match. So now we'll graph these 3 points, and I'm going to start with the vertex. So the vertex is at negative 2 for x and 4 for y. So here's our vertex. Then we have our first point, negative 3, 5, which is just slightly above and to the left. And we have our third point, which is negative 1, 5. And then we're just going to sketch our parabola from there. Now, from here, we should be able to identify our axis of symmetry. So remember, our axis of symmetry is the line that cuts the parabola in half, and we're going to see where it touches the x-axis, and that should be the same spot as what the x value in our vertex is. And it's touching at negative 2. So for our axis of symmetry, we're going to write x equals negative 2, because that's the equation that represents the line for the axis of symmetry. Now, the domain and range are a little bit different. So let's just back up for a moment to these graphs. Okay, so domain and range means if you were to write the ordered pairs for every single point on the parabola, we want to know what values would represent the domain and what values would represent the range. So the first thing you have to know is for the domain, we're looking at the x values of the vertex, or not of the vertex, of every point. And for the range, we're looking at the y values. Okay, so for this top parabola, when you look at the x values, because the arrows are on the parabola, technically, this parabola, both sides will go on forever. And so if you kept going on forever and ever, every point you see for the x value of every point is possible. So every time you write the domain of a parabola, you're just going to write all real numbers. The range is different because notice for the y-axis, the parabola never goes below that red line I just drew. So that means anything above that red line could be, the y value could be anything above the line, but nothing below it. Okay, so what you want to do is you want to write that y can be anything greater than or equal to whatever that place is where we drew the line, which for the y-axis is at -4. Okay, so again, for a parabola, the domain will always include all real numbers for x. There's no limit. But for the range, there will be a limit, and that's based on if the parabola doesn't go below, there's a certain line the parabola doesn't go below or above, then that will be your limit. So if you look at the one below it, again, the domain is always the same. It's going to be all real numbers. But the range, there will be a limit based on, in this case, it'll be the maximum point, because that parabola does not go above that line. So notice it cuts through the y-axis right here at 5. Okay. Now in this case, y can be any number less than or equal 5. We don't want to put greater than because that parabola doesn't go above the line. It only goes below the line. Okay, so knowing that, let's go to that problem we just did and look at that parabola. Okay, so again, we know the domain is all real numbers. But the range, we're going to look at, in this case, the minimum. I'm going to draw it in green, meaning that parabola does not go below that green line. And that green line cuts through the y-axis at 4. So for our range, notice that parabola is above the line. So it's going to be, y can be anything greater than or equal to 4. Okay, and that completes the lesson on graphing a quadratic equation using a table of values, including axis of symmetry and domain and range. Good luck.